All right, now we're going to go ahead and continue to talk about synthesis. So this is something that we've been talking throughout the chapters, and so it's not going to be something that's all too unfamiliar, but we're going to do a little bit more advanced types of synthesis. But at the end of the day, we need to memorize quite a bit of information, and so you need to know all one-step transformations. There's simply kind of no way around this. If you don't know how to do these one-step transformations, you're not going to be able to couple them together into 2, 3-step ones, right? And so my suggestion is to make a chart of all the reactions we've learned. Of course, there's charts online as well. I'll show you one in a second, but it's better to make your own chart because as you write it down and make the chart, that'll help you learn the information a lot better. I'll show you the one I like to use from the internet. I don't really use it, but a good one from the internet. It's from this Master Organic Chemistry website, right, that I've already told you quite a few times is a good one. If you go down to number 12 here where it says alkene, number 13 here where it says alkyne reactions, and then you go to this fifth one where it says synthesis 5 reactions of alkynes. Click on that. And then scroll down for number 4, a full reaction map PDF for first semester organic chemistry, alkanes, alkyl halides, alkenes, and alkynes. Click on that link, and then click on this printable PDF version, I guess. And it'll bring up a nice PDF of all the reactions we've learned. So we've learned all of these. He makes it seem like there's a lot more than there is, simply because there's a lot of repeats here. So it goes up to like 55 or something. There's not nearly 55 different unique reactions. A lot of them are, add Br2 versus Cl2 versus I2, right? That's all the same thing. But anyways, I'd recommend making your own chart, or at the very minimum, copying this chart and kind of looking around it. And so you can see all the different things that we've done in this course, right? So if you take a look down here, we have alkanes, right? That's kind of what we started here. There's only one thing that we can do with alkanes, and that's still true, and that's make our alkyl halides, right? So that's pretty much the only thing we can do there. Once you have your alkyl halides, you can do a bunch of different substitution reactions, which is all of these are just substitutions. And so these go through the SN1 or the SN2 pathway. We learned all of these except for this azides, but it's really not too complicated. You just need an N3- nucleophile. Then the other option, instead of doing substitution, is to do elimination, right? So this is our E1 and our E2, right? And that'll lead us to alkenes. And from alkenes, we learned a whole bunch of different addition reactions, right? We added all kinds of different stuff to alkenes. And then, of course, we also learned how to go from alkenes to these dihalides back to these alkynes, right? These alkynes are a new unit. And with these alkynes, we can do additional addition reactions, right? These are pretty much the same as the alkene reactions, just with alkynes now. So it's just more addition reactions. But in order to do the multi-step synthesis, you do need a full toolbox of reactions that you can use. So you want to take a look at this chart and be able to identify these numbers, right? How do you go from an alkene to a vicinal diol? How do you go to a cyclopropane? All this kind of stuff. Before you can start stringing things together, you have to be able to go in a one-step fashion.